All right, so in this video, I'm going to talk about the internal rate of return. So for the internal rate of return, the internal rate of return is the discount rate that makes the present value of all the future cash flows identical to the project's initial cost. In other words, it makes the net present value exactly equal to zero. So basically, we're gonna find the discount rate at which the net present value is precisely equal to zero, and that is going to be our internal rate of return. One of the ways that you can think about that then is that the IRR, or internal rate of return, is essentially the rate of return generated by the project itself. So that's kind of the idea here. Now, if you think about that, let's kind of take a look at the example that I've been using so far for capital budgeting. So if I'm looking at this example, basically, if this was my discount rate that I had over here, what we're looking for is a discount rate that would make the net present value exactly equal to zero. So what if I tried 12%? Well, net present value is still positive. So what if I tried 14%? Still positive. 16%, still positive. 22%, negative. 22% is too big. So I'd have to make it smaller. So 20%, 19%. That's too small. 19.5. Need to make it bigger. So if you're looking at that and thinking, well, this sounds kind of horrible, right? Trying to find this. Basically, what it comes down to is what we're trying to do is we're trying to find the discount rate that I would put in that would make all these present values exactly equal to that initial cost. In other words, makes that net present value exactly equal to zero. And so we could do that by guessing values, kind of like I just did. But that would be extremely painful. And it turns out that there is a better solution to this. So the better solution to this is we're going to use Excel. Okay. So we're going to use Excel because Excel can do this very, very rapidly. So let's go ahead and take a look at that. So if I'm going to calculate the internal rate of return, or the IRR, Excel is a function for this. So I just do IRR, open parentheses, and now I have to highlight all the cash flow values. So I highlight all of them. Remember, for net present value, you highlighted from 1 to the end, and then your 0 went outside the function. But for the IRR, you highlight all of them. Okay, so I highlight all those cash flows, close parentheses, hit enter, and bump out the decimal places. Lo and behold, 19.639% is the value that we wound up with here. Okay, so 19.639%, that was actually pretty close to what we had at one point there when I was guessing of 19.5. So basically, that's the IRR. This is the number that if I plug this in, I get a net present value of zero. And to see that, I'll go ahead and copy that value. I'll paste the value over here. And sure enough, my net present value is now zero. Okay. So if I put that in there, I get a net present value of zero. So that's the IRR. And I can think of this 19.6% as being the rate of return generated by the project. So let's talk about how we interpret the IRR then. So if I'm thinking about how to interpret this, basically, if the IRR is higher than the hurdle rate, in other words, if the IRR is higher than the risk-adjusted cost of capital, we like the project. If the IRR is less than the hurdle rate, not like the project, we should reject it. If the IRR is exactly equal to the hurdle rate, project neither attractive nor unattractive, we'd basically be indifferent. So what that basically translates to is something relatively simple. So if this is my required rate of return for the project, given the risk, and it's 10%, the project, based on this calculation, is generating 19.6%. So we're generating 19.6%. We only require 10. We're getting extra. We like that, right? So if the IRR is higher than what's required, it's good. We like it. If the IRR is less than what's required, not good. We do not like it. And if you think about this, this ties in exactly with the net present value. Here's the idea. Basically, I could have put a required rate of return in here of up to 19.6% and still had a positive net present value. So I could have required up to 19% and still had a positive net present value. I'm only requiring 10, which means if I'm only requiring 10, that would make the present values higher than if I use the 19. So when I see an IRR of 19 required 10, what that implies is at the discount rate of 10, my net present value would be positive, which we like. So the net present value would be positive at the discount rate of 10. I could have pushed the discount rate all the way up to 19.6 before I got to basically a zero. And when the net present value is zero, I'm on the fence. If I push the discount rate up to 20%, now the net present value is negative. Now I wouldn't like it at that point. So from that standpoint, that would be basically how I would interpret the IRR and so forth. Now, it's worth kind of noting what's going on behind the scenes here. So if you think about this from a time value money standpoint, for this first cash flow, basically what you're doing is you're taking the $20, so I do 20 over, and I'm going to kind of work on making this kind of present this nicely. So 1 plus basically R, which would be my required rate of return here. And basically, I would actually show this to the 1. So basically, if I was doing this out in terms of the kind of the longhand way of doing things, what I would have is the calculation for the present value of that first cash flow would look something like this. $20 divided by 1 plus R raised to the 1, right? And for the calculation for the second term, I'd have the $30 divided by 1 plus R raised to the 2. Then I have $30 divided by 1 plus R raised to the 3, and so on. If you're wondering, why are you talking about this? Here's why I'm talking about this. Notice that in the denominator here, I've got 1 plus R. But in this second term, I would have 1 plus R, that whole quantity squared, which would be a polynomial, or a quadratic formula, actually. Then for the third, I would have the $30 over 1 plus R to the third, which would be a third order polynomial, and so on and so forth. If you're thinking, why does this matter? Here's why it matters. Think back to high school. So if you think back to high school, when you're solving algebraic equations in high school and you're solving quadratic equations and things like that, with certain types of functions or certain equations, it was possible that more than one number could solve the equation. So, you may have solved an equation where the answer could have been -2 or +2, and either one would have solved the equation that you were looking at. Well, similarly, with the internal rate of return, if I have some non-normal cash flows, in other words, if some of these cash flows in the future are negative, it's possible that there's more than one number I could use as a discount rate that would make the net present value equal 0, kind of like that old quadratic equation kind of thing that you did back in high school. So it's possible there could be more than one number. The reason why that's worth noting is this. If you have some negative cash flows out in the future, it's possible you have more than one number that could produce a 0 net present value, and you could have more than one discount rate that would technically qualify as an IRR. Here's why I'm mentioning this. Excel doesn't tell you. Excel just says, I found a number that made net present value 0. It doesn't look for any other numbers. It just says, hey, this one worked. Here it is. So if you have some negative cash flows out here, you might get an IRR, but that might not be the only IRR there is. You need to check for that. And in a subsequent video, I'll talk about net present value profiles, and that would actually be how you could check for it. If you only have positive future cash flows out here after time 0, then you're not going to have a problem. You're not going to have more than one IRR. You can just trust the IRR you get and you're good. But if you have if you've got some negatives out here, just kind of beware. There is potentially a problem there. Now, if I circle back to my slide here for a moment, there is one issue associated with the IRR that's worth noting, and that is the IRR assumes that I reinvest at the going rate of return for the project, okay? So let me talk about that for a second. So if I look at this particular project, if this is my normal required rate of return given the risk, 10%, this IRR assumes that, hey, when I get cash flow 1, this $20 at the end of year 1, I'm going to reinvest it in another project getting almost 20%. Well, hold on. If normally I require a rate of return of 10% for projects of this level of risk, if I had a project that was offering 20%, shouldn't I have already done that project? The answer is, well, yeah, right? I should have already done that, which means if there was a project offering 18%, shouldn't I have done that? Absolutely. 15? Sure. 12? Yeah. 11 and a half? Yeah. 10 and a half? Yeah. 10 and a quarter? Yeah. Basically, any project that was over 10%, I should already be doing that. So I probably don't have another project lying around that's going to get me almost 20% to invest these cash flows in. So what that means is when this IRR calculation occurs, it assumes I reinvest in an identical project, which might be a bad assumption if this project is looking very atypical. So if the project is very atypical, so in other words, not typical, then that kind of might be a problem. And basically, here's the result. If the project looks good, the IRR will say it looks good, which is correct. But it might be a little bit optimistic about how good it looks. So it might overestimate just how good it looks. On the other hand, if I had a project that actually looked bad, it will assume that I reinvested in another equally terrible project, which is also probably not true. So if the IRR was, say, 5%, I required 10, I concluded, bad idea. Well, the reality is the IRR is probably overstating how bad that is because it assumes I reinvest in a project that is equally bad. So the IRR will point you in the right direction, but it might potentially overstate how good a good project is and how bad a bad project is. The closer the IRR gets to what's normal, the less that's a concern. All right. Thank you so much for watching. Have a great day, and I'll try to get back with some more videos soon. Thanks so much.